Hey guys, this is one of my inventions. It's a hyperspin engine. It's a series of engines, one in front of the other. It makes its engine speeds go higher than anything beforehand. Makes fastest motorcycles, fastest sports cars, fastest jet engine, fastest train, you name it. It'll speed up any kind of known engine known to man by hyperspin engine. And what's the simplicity is that makes it work is so simple. For example, here we have a train. Normally, the fastest maglev train that I've read about real quick. Its speed is 267 miles per hour. That is the fastest train. Obviously, the motor that it has can deliver that speed of 267 miles per hour. Now, I could design a faster train than that using this series of hyperspin engine. Basically, for example, let's say each engine compartment, we have in this case several compartments of engines. Each engine can produce the same speed power that we want to reach. In this case, the train itself, this train, I don't know if I can pronounce this correctly, Shanghai Maglev train, it goes up to the speed of 267 miles per hour. But my goal is to go over 10,000 miles per hour. Now, how are we going to do that? Well, the hyperspin engine. Like I said, the engine can be built for any motor in the world to give it speed by doing in series, one in front of the other ones. In this case, we have each engine. Let's say we have the same capacity of motor or speed they can deliver. Let's say each engine can deliver 267 miles per hour. So let's say each engine can deliver the same power, 267 miles per hour, 267 miles per hour, 267 miles per hour, 267 miles per hour, and so on. So as each engine spins this direction, this is just a so you can get the understanding how it works. This spins this way, the motor inside, and then the other one in front of it, it's going to spin the same velocity, same power, and same RPMs and stuff, and same capacity of speed. So each engine spinning, it could deliver speeds of 267 miles per hour each motor. But because the one in front of it, it's always going to speed faster. So this motor spinning, see that spin right there? So this motor spinning, but the one in front is always going to spin faster. And the one in front is going to spin faster. So the one in front, it's always going to spin faster than the one in the back. Even thought they're all the same speed. They're all spinning at the same speed. But because they're in series and they're attached to the one behind it, so the one in front of it always going to spin faster and faster and faster than the one behind it. Even thought they all spin at the same velocity. It's called hyperspin engine. That is my invention, my technology that I developed. That basically, in series, engine can reach an amazing speed, unbelievable speed, because the engine in front of it always going to spin faster than the one behind it. So always one in front, always faster and faster and faster and faster. Even thought they all spin at the same velocity. That's why I call it hyperspin, because there's no limit on how fast you can make this engine rotate in RPMs, in G-force, or in mile per hour velocity. So if you could derive each engine's capacity of 267 miles per hour capacity, that's how much capacity each engine can deliver to high speed. Imagine if you have the same capacity engine multiplied by several engines that just have the same capacity. Remember, each engine spins it faster and faster and faster and faster, and it could go infinite until you reach a large mass. But in this case, we're using this to power a train to reach the speed of over 10,000 miles per hour. So if each engine can deliver a speed of 267 miles per hour, right? Each engine compartment. And if you have 10 engines, 267 times 10 engines, and that's going to equal to 2,670 miles per hour. So if you have, each engine equals 7 miles per hour, multiply it by 10 engines, that equals 2,670 miles per hour. See, but if you want to reach 10,000 miles per hour, then you add more engines to it. Remember, each engine makes the other one in front of it move faster. So let's say you have 40 engines. 40 engines times 267 miles per hour equals, well, that's just 40 anyway, it's equals 10,680 miles per hour. And that's velocity right there. You can add more velocity, more power, more energy to the motor as a whole by adding more motors. This can work for race cars. Always have the same motor capacity in front of it, in front of it, and in front of it, in series of several ones, and always going to make it faster, spin faster, spin faster. The same technology speed. That's why I call this hyperspin engine. It's a engine in series, because they are interconnected. And the one in front of it is going to spin faster than the one behind it, making it a hyperspin engine, making it spin at a hyper velocity. So I'm going to write this hyper velocity. So it's going to be a hyper velocity. The only thing they have to design for this is basically how to prevent it from running off the track. That's pretty much it. Because that velocity, you need something else. You need magnets or something to keep it in a track. But you can reach up to 10,000 or more miles. You can reach the same velocity as a jet. But you have to know to keep it in the tracks. Like I said, this technology can reach the speeds whatever you want. I mean, 10,000, 20,000, 30,000 miles. The speed's there. The power, the speed, the concept for it's there. Of course, the fuel is going to waste a lot of fuel, because now we're using not one engine, you're using several engines, but the fuel is going to be more, but the velocity is unlimited. It can go as fast as you want, but you need the technology to keep the trains in place so they don't run off the tracks. Well, anyway, this is a hyperspin engine in series to reach hypervelocity. Thank you, guys.